Okay, thanks for having me. This is Jacek Laskowski with my talk and talk about Apache Spark and Spark listeners. This is just a kind of a summary of what I learned about Apache Spark for the past 1 year or so. I'm spending my time with Apache Spark exclusively these days. So this is deep dive into monitoring Spark applications using web UI and Spark listeners. The other talk, the talk before me, before this talk, it was about how to monitor your Spark applications. And there was this scope. I just remembered this scope, this Greek word. He used Spark listeners too. As a matter of fact, what you will see in a moment, web UI is all about Spark listeners. So I'm pretty sure that he spent some time with Spark listeners too, just like me. But hopefully I'll bring you the news how to make your Spark experience even better by learning what it is to work with Spark web UI and Spark listeners. Okay, so just briefly about me, a couple of, not as is usual, a couple of slides, just one slide. So I'm now independent Scala Spark consultant, working exclusively with Spark and Scala these days, slowly progressing towards this ecosystem around Spark, MongoDB. Yeah, hi Ross. I'm hoping you are here. Cassandra and Aerospike and Kafka, obviously, Kafka too. And so I'm offering development and training services these days just to improve my understanding of Apache Spark and hopefully bringing the news to you as we are here now. So I'm taking notes, mastering Apache Spark 2.0 at Gitbook. So there are over 1,200 pages about Apache Spark, very low-level details, because this is how I'm looking at Apache Spark, through changes, through the code. So whenever I see something interesting, something people might like, just like today, you will find it here. So bit.ly mastering Apache Spark. This is the place which I'm using to communicate my knowledge, my skills to the audience, to the public. I'm among contributors to Spark 1.6 and 2.0 too. So I worked with brilliant brains behind Apache Spark and learned this great stuff I can share today. So I'm pretty sure that everyone has already seen this picture. This is the picture that's supposed to tell you what Spark really is under the covers when you deploy your Spark application to a cluster. So there are 3 cluster managers supported by Apache Spark these days. So this is Apache Mesos, Hadoop Yarn, and built-in Spark Standalone. So all these clusters, and there is another 4th one written in Clojure, can't remember the name. But there are these 3 cluster managers. And as you can see, there is this driver program, your code, that hosts SparkContext. SparkContext is the heart of your application, is the heart of your Spark application. Without SparkContext, you can't do anything. You can't do nothing with Apache Spark. So you need to have this SparkContext, either implicitly or explicitly. Eventually, you need to talk to cluster manager that offers you resources to host your application. And this application is shipped to working nodes, part of this cluster manager offering, to host executors. And then run tasks. There are multiple tasks running simultaneously. And the reason I borrowed this picture was to have this anchor to show you that there is this distributed environment, your application, written as if you were on one single JVM, but this is not the case in production. So you've got that many JVMs, at least 3 now, but you could have thousands of JVMs, and you need to know what happens under the covers when your application is up and running, right? Right. So you need to have a console, web UI, to show the statistics about, the gore details about the performance and the measures that you can use to improve performance of your application. So as you can see, after Cluster Manager assigns or gives worker nodes to your program, SparkContext will communicate directly with executors. How is this happening under the covers? Well, Apache Spark uses Netty under the covers, and it uses for RPC communication. So all the communication between executors and SparkContext, the driver, happens through the wire, over the wire, using Netty. So Netty is the low-level infrastructure for sending messages about current status of your Spark application. Okay, easy? Okay, good. So, yeah, so you've got a lot of RPC messages sent between, the driver and executors. And the reason for this is to learn about what happens in this distributed environment called your Spark application. So since we are in distributed environment, we need to have this console, this one single page where you can see, all the statistics. So event sources, you've got DAG DAX scheduler. This is the main component that looks at your program and tries to, looking at the RDD lineage, tries to come up with the best execution plan with stages, with tasks, together with task scheduler implementation. Impl, there is only one task scheduler available now or currently in Spark 2.0. So tasks scheduler Impl, but you can provide your own. Yes, it's possible, but it requires more skills. Then there is this piece or component called scheduler backend, with coarse-grained scheduler backend being the main component or scheduler backend used currently in Spark 2.0. There were other scheduler backends. There are customized scheduler backends for Yarn, for Mesos. There is this coarse-grained, and there was also the other fine-grained scheduler backend, but it's deprecated now. So soon to be removed from the source code of Apache Spark. And there are also executors. So all these components talk to each other to exchange information about your Spark application. And it doesn't really matter whether you are using RDDs. You shouldn't these days, but you might. So either it's RDDs or Spark SQL or graphics or Spark streaming application or Spark SQL. Spark SQL and Spark MLlib. I'm not sure which one I mentioned already. But anyway, it doesn't really matter. Under the hood, you talk to SparkContext. And SparkContext talks to this distributed environment to execute your tasks. So Netty-based RPC is used to communicate between worker nodes, executors, and the driver. And there are there are a few internal event buses. And these event buses are just single-threaded components that process all the events that were sent during execution of your Spark application. So to me, whenever I'm asked what Spark application is, it's just a language, it's just a DSL to express distributed computation using this distributed environment like Apache Mesos, Hadoop Yarn, or built-in Spark standalone. Okay, so you see there are a lot of communication between all the nodes in this distributed environment. So what happens when SparkContext starts? When your SparkContext starts, this is the moment where your Spark application starts. So this is the only moment where you can say, my driver or my Spark application is up and running. Only after SparkContext is fully initialized and ready to launch, to submit your tasks to DAX scheduler and later to task scheduler Impl and others. So you need to have fully working SparkContext. This is the heart that need to be, you know, that needs to be ready to launch your tasks. So SparkContext, among the things SparkContext is doing to initialize itself, it starts Live Listener Bus. There are there are many listener buses. There are 3 or 4 listener buses, but there is one main live listener bus that's responsible to process your events as your application is live and kicking, hopefully. So that's the reason for this live. Live should also, there is also this, the other listener bus for history server when your application is already gone and no longer up and running. So it also registers something that's called JobProgress listener. This guy is responsible for collecting all the data that Spark UI, your web UI, will use to show the statistics. So all the statistics are available only because there is this JobProgress listener that collects this data. So now I'm more often, I'm thinking about this idea of disabling web UI to lower the pressure on the driver's JVM to hopefully to make it faster. Because as you can see, Spark UI through this JobProgress listener and other listeners will collect data, right? It's on JVM. So if it's on JVM, there are a lot of data stored in JVM space. So at some point, JVM might decide to launch or run GC that might, slow your application. So I'm not sure how effective it is or how much performance your application could be by disabling Spark UI, but you can disable it. It's enabled by default, but you can disable it by Spark UI enabled. So by falsing this property, you can disable it, and hopefully you won't start all these listeners. There are other listeners like environment listener, there is storage status listener, there is executors listener, storage listener, RDD, blah, blah. There are a lot of listeners up and running only to make you more comfortable with this distributed environment. Okay, and they are all registered with Live Listener Bus. Good. So after SparkContext is fully initialized and ready, you can start launching your tasks or running your jobs that will eventually become a set of task sets with sets. So you have this web UI and Spark UI, or also known as Spark UI. Under the covers, this class that's responsible for this is called Spark UI. It extends web UI. So this Spark UI or web UI, whatever you call it, or Spark application UI, looks like this. But it's only possible because all these Spark listeners collected all information about your distributed computation, called Spark application, your Spark application. So you have this jobs, stages, storage, environment, executors, SQL, streaming, thrift server, and other tabs that are available depending on the console you are using in Spark. There are many consoles you can use, and I can see that people are usually confused with Spark standalone console, web UI, and this web UI. And the reason for this is perhaps because they are all available in Spark out of the box. So people will say, so is Spark standalone Spark? Well, in some sense it is, but it's just cluster manager to help you get going with distributed environment rather than running your computation in local mode. Okay, so it's by default available at 4040 port. You can change it by specifying different Spark property, but by default it's available on 4040. If it's not on 4040, it means that someone else took over this port, so Spark will try to find next consecutive port or next free port after 4040, 4041, 4042, and and on and on. So it might take a while if you have this 4040 and others busy, because it will try to bind to this port. Okay, so it's available at 4040, and it's mostly empty because at startup, because there are no computations that have been finished yet, so there is nothing to be displayed other than under environment and under executors. There are two tabs that are available with information that you can explore. But the very first tab, or page, whatever you want to call it, this tab, Jobs, is open, and it's usually it's empty when you start your Spark application. What's important is that this UI is only available when your application is up and running. When Spark application is up and running, this UI is available only. Once your application, well, you now know that it's not about Spark application, it's about SparkContext. Once you stop your SparkContext, this UI is gone. Okay? So your application might be up and running, but if your application decided to stop SparkContext, this UI is gone. That's what people find very confusing. How is it that my application is up and running while my UI is not available? Well, there are multiple reasons. Since I'm a Spark consultant, I usually start this answering such questions with, it depends. It depends on what you're doing, not how much you pay. So it's only available when your Spark application is up and running. If you need to have all this information collected while your application is up and running, you need to enable something that's called Spark History Server. As a matter of fact, this is the UI for your logs that were enabled, that were collected while your application were up and running. Okay? So yeah, Spark History Server. This is not the right moment to ask this question. Do you have any questions, right? Because we've got 5 minutes, okay? So if you've got any question, spare it for this 5 minutes at the end, okay? Good. So as you can, as I said, Spark UI is just a bunch of Spark listeners under the covers that collect all the information that Web UI may ever show you. So it's that Web UI can't show you more than Spark listeners couldn't collect. Well, pretty much with some exceptions, but minor exceptions. So at the very first page, in this job page, you've got JobProgress listener that combines all the informations in over 20 internal registries just to make lookup faster. And you've got this executor listener to just show you this event timeline for executors. You may have noticed it while working with Web UI that there are two parts in this event timeline, and this executor swim line is something that executors listener takes care of, while the other jobs is taken care of by JobProgress listener. Good. And there are other tabs with other listeners. So you've got this live listener bus, this guy who is responsible for intercepting events and passing them or forwarding them one by one listener at a time, one event at a time, to Spark listeners. So it's created when SparkContext starts. It lives in the driver. The driver is the part that executes your Spark application, that controls your Spark application. That's where task scheduler implementation lives. And it can live on your laptop where you Spark submit your application, but can also run in cluster deploy mode on one of the many machines that cluster manager assigned to you when you deployed your Spark application. So when I say it runs locally, I mean on the right machine that I call local, which might not be local. It might not be your laptop. So Live Listener Bus is just asynchronous SparkListener event bus. So it processes these events. Oh, I'm scared. We've got only 10 minutes. I've got half an hour to talk. Okay, so we've got this. we've got these events, and there are a lot of events to catch, to process. So think of it. You can have multiple Spark listeners, and you've got lots of events flying from executors to your driver. So think of it. A lot of processing is going on only to show you the nice human-friendly UI. So at some point you might decide to disable it, just hoping that it might improve your Spark application performance. So we've got also Spark specialized or custom live listener buses for Spark streaming, including the latest and greatest structured streaming, and Spark History Server. Spark History Server has its own listener bus. It's not live listener bus, but it behaves as if your application were still up and running. It just reads JSON events or JSON encoded events from a file and just shows you the web UI as if your application were up and running. Good. So these are the events. So you've got 18 main events with 24 total. At least that's the number I came up with after counting all the implementations of Spark Listener event class, or it's an abstract class, I believe. So 24 events, and there are custom events for Spark streaming and structured streaming. So that shows that you can build your own events, so you can pass this information from executors to the driver and between components of the driver. If you are more visual, if you want to see this in picture, that's my humble attempt to create something visual. So this is SparkContext. It uses DAX scheduler and uses Live Listener Bus under this Listener Bus attribute property. So DAX scheduler will fire all these events. So it will announce the stage, not to confuse with Spark stages, that the stage, the moment in time where your Spark application is. So DAX scheduler is responsible for announcing its state together with the other components too. So through posting these events to Live Listener Bus, you can be told that this is the stage that your Spark application is currently in. Okay, so there are all the built-in Spark listeners. There are a lot of Spark listeners, as you can see, and there is a lot to learn from. So you can use these as the guidance to create your own class, your own Spark listener. So you can so event logging listener. This is something that Spark History Server uses. There is a stats report listener that you can enable to see some stats after finishing stages and jobs. Yeah, print it out to the console. That may or may not be something you might find useful to improve performance of your application. And others. And by looking at the name of each Spark listener, you may imagine what this Spark listener is for. So when you see environment listener, you can imagine that it's responsible for bringing all the data to event tab in web UI. So what it is to be developer, Spark developer, Spark Scala developer, hopefully using Scala. So hopefully, because I'm with Scala and I love this language comparing to other languages. I'm not saying that this is the best out there, but this is good enough for my Spark developments. So Spark Listener is just a developer API. You can use it to extend what's available in Spark out of the box. So by extending this Spark Listener, you will get all the methods, all the handlers being no ops, so no operations, they do nothing, and you can just override one method you are that's responsible for event you are interested in, and have information that Spark shows you through web UI. Okay, you've got also this Spark Firehose listener that's also kind of a base for your SparkListener endeavors or development with on event, so you can pattern match on this SparkListener events. So it's up to you what approach to take. You can start with SparkListener Developed API or Spark Firehose Listener. They are equivalent, but they show this interface is slightly different from API perspective. You can register, or you register your SparkListener, your custom SparkListener, through SparkContext at SparkListener, or you can use Spark Extra Listeners Spark property on command line through --conf or -c, and define these Spark listeners. So yeah, that's what you can do. So on my GitHub, shameless plug, on my GitHub there's a complete custom Spark listener, not very sophisticated, but just to show that it's possible, and it's part of this documentation I just described. So when you go to this GitHub, Jacek Laskowski Spark workshop, and you go to this solutions custom Spark listener, you will find this custom Spark listener. Its aim is only to catch this job start and stage completed events. That's it. Okay, so you can also find this. Well, I was supposed to, to show you the demo, but given that we've got only 4 minutes, I'd rather ask you, answer your questions than show you this in action. Apologize. So this source code, entire source code, is available on my GitHub with notes how to run it, how to execute this custom Spark listener in this part of my Gitbook about Apache Spark. So what are the use cases that you can think of when you are dealing with Spark listeners? Well, as you can see, this is the Stack Overflow question about how to display step-by-step execution of sequence of statement in Spark application. And there are 2 answers to this question, and my answer was to use Spark Listener. And the reason for this is that through Spark Listener, you can get this information. So it depends what this OP asks for, but given this information, I believe that Spark Listener is a good solution. There is also another question on Stack Overflow about how to know executors APIs, or all the APIs of all the APIs of all the executors available for your Spark application. And again, this is Spark Listener. Spark Listener will give you this information, will give you IPs, will give you all the information that you can ever expect from web UI. And that's it about Spark Listeners. I hope it's entertaining as well as welcoming, so you will try designing, developing your own Spark Listeners. You can catch me at Twitter under this Jacek Laskowski handle. Also, you can ping me on this email. So that's all from me. Do you have any questions? Thank you.
And for anyone who has questions, we have 2 mics set up here and there. Just a reminder, you do need to get pretty close to the mic in order for it to pick you up.
Yeah, that just shows that Spark Listeners, web UI, and Spark in general are so simple these days that there are no questions. Yeah. Sorry. Or I'm such a good speaker. Both ways, it's very good. Thank you so much. And
we have one question.
Oh, there is one?
Sorry, I have a question.
I apologize. There is one question.
Yep. So thank you for your talk. I'd like to know whether there is any way to provide an external ID for the Spark jobs started, so you can actually know what external application has started the Spark job.
Okay, all jobs, all stages, all tasks are numbered internally by Spark. So you cannot change it, but you can know about the IDs and identifiers. So everything in Spark is uniquely, globally counted. So depending on what you need, whether it's stage or job, you need to ask these identifiers. You need to request these identifiers from Dex scheduler. While for tasks IDs, you'd ask task scheduler implementation, or you just subscribe your Spark listener and you will get all this information. Hopefully I answer your question. If not, ping me offline, okay? Thank you so much. Okay, that's all from me, guys. So thank you again.